unless you're a major. For some reason, major always gets recorded. All right, so our reaction is the acid plus base. And so the sodium and the hydrogen are going to switch places. So sodium, alkyl, and H2O. So the H2O is optional. A reminder, I had a typo on the answers. So the answer for that is 7.02. And the answer for the next one is 10.17. There must have been another question at one point. So we have to figure this out. And I started us with grams so we could do practice in a different way. So if you have grams, we want to change our grams to moles. And periodic table, we add up HO and Cl, so 52.5. And that gives us 0.00667 moles. So something I emphasized earlier, and I'll emphasize again, you need to keep 3 sig figs after the zeros. Be careful of the zeros, because gaining or losing a 0 is going to throw you off, and that's one of the biggest mistakes. So 0.00, and then we need 3 numbers, because it does make a difference if you round too much on titration. All right, the NaOH, 0.01 liters times the 0.180. And again, I usually see like half of the students like to make columns. And so if you like that, you can put nice clear columns in there. And that's going to be 0.0018 moles. And this side is a 0 because it's a titration problem. We have nothing over here yet. All right, limiting reactant, whichever moles is smaller. And somehow you can know you're doing this okay. It is almost always the NaOH or the HCl that is your limiting reactant. So almost always that's what limits us. It is not an always. So post equivalence, we saw that's where you have excess. Right. So this is gone. The NaOH has, we haven't added enough yet to be at the equivalence. And that is the number of moles that we add to our product. And then this is going to be and then label. This is, sorry, I don't know why I wrote conjugate acid. This is my acid. This is my base. So when you have the 2 pieces, that actually will help you to put a label with them. So when you write your Ka expression, we have it up there, right? We have our Ka expression. Did I give you? I gave you the Ka. So again, where are we in the titration? We're in the buffer zone. My pH, that's why the pH didn't alarm me, but my pH is around the exponent. So we haven't neutralized it yet. It's just that we're dealing with an exponent of 8. So my pH is going to be up in that range when we're working with a buffer. So you're going to have the X times the 0.0018 moles over the 0.00487 moles. So I keep asking it in hopes it will, or when you go back and watch this at some point. We do not need the volume because you have both. If you have both the acid and the conjugate base, keep it in moles. When we get to the X squared problem, we're going to have to use molarity. All right, your X is your hydronium, and you can go from there. Questions? All right, equivalence. We write our chart again. So the Hockel, the NaOH, and So what's the one piece of information I can use from part A of the problem?
Initial?
The initial moles. I already figured it out for the, whatever it is you're titrating. So the weak, in this case, the weak acid. That moles is still my initial moles. The NaOH at equivalence is now the same. That's what equivalence means, is these two are the same. So the strong is always changing at every point in the titration. So on the study set, I know the one page, it's just like kind of like this page, it's different titrations. And that's then why I have the lab, the worksheet and the lab, it walks you kind of like we did on the previous pages. It walks you through one long titration, or on the lab, like 3 different titrations. All right, these are both gone. They reacted. It's the perfect stoichiometric, perfect reaction. It's like back in Chem 221, all of the reactions were always perfect. And really, it's only this one point that is perfect. So these have reacted. So all we have left is the sodium alkyl. This is the conjugate base. You have to use Kb. So your Kb is, right, 10 to the negative 14 divided by the Ka. It's going to be x squared, but you cannot use just the moles because it's not a ratio anymore. So we do need down here the total volume. All right, so let's go through finding the volume. We know the volume of the acid because that doesn't change. That was our initial, that's this piece. So this is 50 mils. But the NaOH keeps changing, it's at different points. So to find the NaOH, we take the moles and we divide by the NaOH's molarity. So the moles cancel, the volume will flip to the top, and we will get 0.037 liters. This, of course, is 0.05 liters, and we add them together. So again, usually this step to find the volume I have as a separate question. So this is 0.087 liters. And again, I can't emphasize enough, your X, state what it is. It is the hydroxide. I get a number, yeah, 1.48 e to the negative 4. So when you go through all your steps, so negative log of X is going to be the POH. You give me a number and then you can just state, so your pH again is 10.17. Why does this answer make sense? And then I want to go through the box.
Because we're left with the conjugate base, so it's a basic solution.
All we're left with is the conjugate base. These guys are gone. So it's a basic solution. So only conjugate base. So pH is greater than 7. All right. So this chart is actually really simple. We know some of the answers already, like right here. That's why I actually gave you X here so we could fill it in. X was my hydroxide. We said that. So, all right. This chart is molarity. This was molarity because if it's an X squared problem, everything is molarity. Hydronium's easy. If you know pH, how do you find hydronium? 10 to negative pH, right? So 10 to negative 10.17. You can give the number. I don't know what the number is without finding my calculator. All right. The other numbers are actually all up here. This was x squared. This was x squared. That means something else also is x. Let's go back up here. I'm going to write my generic formula for Kb. Kb is hydroxide times the conjugate acid over the base. So both of these, that was our x squared. So hydroxide we got, where's the conjugate acid? Well, here's my acid. It's the only thing left with the H. So this is also X. Please realize if it was a problem where it was a weak base and a strong acid, this would be different. But in this case, this is the conjugate acid and this is the hydroxide. So this was X and this was X. All right, these are actually the same. Sodium and the alkyl. Up here, I wrote them as one. This is the conjugate base that I called up here. This is the 0.00667 moles over the total volume. And the sodium is the same thing. So we can find that number is 0.0767 molar. And so this must be the same, 0.0767 molar. The conjugate, we write it as a salt. So those two pieces go together. Questions?
So technically at equivalence, you would assume that all of the reactants are consumed. And I see that the HOCl, that's like infinitesimally small. So is it just considered that it's all consumed?
So there's no zeros because there is actually an equilibrium. This equation is not the equilibrium equation. This equation is the NaOH reacted. And then what happens is we're in an equilibrium. So technically it's a Kb, so we would have the alkyl plus the water. And now you have an equilibrium. And so that would go back to the alkyl. And the sodium doesn't matter here at this point. But this is the Kb expression that these are going back and forth. And we would have hydroxide. And that's why these are X. Now, how Devin worded that question, this is like an awesome question. This is really small, but it's not zero. Up here in this chart, it is a zero. Because the mice chart, that's actually the other big reason why it's not an ice chart. It's not an equilibrium. The Ka or Kb then is a second piece that is happening that is where the balance piece is. This is where the Ka, Kb come in that we then plug to solve for pH. Great question. You should get another bonus point for that question. All right, anybody else have a question? And Olivia, you can get like 3 bonus points today. You can all draw beautiful mice on your worksheet. And all right, I'm going to stop recording.